Okay, in this video, we're going to continue our discussion of decision analysis under uncertainty. We've already read this question, so if you'd like to reread this question, please see the previous video. But in this video, we're going to get into expected opportunity loss and the expected value of perfect information. So again, we're working with a YouTube series. We're trying to decide where to invest our dollars in YouTube. So let's go ahead and dive into this question. So A, imagine you're able to hire an analyst who has experience to tell you what type of market condition you might be able to anticipate in the future. The analyst suggests that market condition A will occur with half of the chance of market condition B, and market condition C will be 2.5 times that of market condition B. And then it's asking us, well, what is the expected opportunity loss? Okay, so expected opportunity loss is simply the sum of all possible regrets of alternatives that are each weighted by a probability of the state of nature for that regret occurring, okay? And for the expected opportunity loss, what we're going to do is we're going to select the decision with the lowest expected opportunity loss. But before we can get there, we first have to try and figure out, well, what are the probabilities of each of these market conditions occurring? So let's just start with what the question has told us. So the analyst has said that market condition A will occur with half of the chance of market condition B. So the probability of market A is equal to 1/2 of the probability of market B, right? This is just what the question has told us. And they've also told us that market condition C will be 2.5 times that of market condition B. Okay, well, that's interesting. So the probability of market C is going to be 2.5 times the probability of market B. Right? What we know for sure is that one of these three states of nature, so either market condition A, market condition B, or market condition C, is going to occur. So what does that mean? That means that the probability of market A plus the probability of market B plus the probability of market C is equal to 1, right? One of those three events are going to happen. We just need to figure out what that is equal to. Now, one of the things we can do with this information that's given to us is we can rewrite this equation all in terms of market B. So we previously said that market A was equal to 1/2 of market B. So what we have then is 1/2 of market B is equal to market A, right? We said that right here. Then we have market B plus the probability of market B. And our question told us that market C was equal to 2.5 times market B. So this just means that 2.5 times market B is equal to market C, which then all adds up to 1. So we can rewrite this then. Well, 1/2 is also equal to 0.5. So 0.5 market B plus 2.5 market B is 3 market B plus 1 market B. Like, this is really, it shouldn't be P. This should say, 1. So that gives us 4.5. Oh, sorry, not 4.5. This gives us 4 market B is equal to 1, right? 4 times market B is equal to 1, which means that the probability of market B is simply equal to 1 over 4. Which means that market A if market A is equal to 1/2 of market B, then that means that market A is equal to 1/2 times 1/4, which gives us 1/8 or 0.125. And if market C is 2.5 times market B, well, this means that 2.5 times 1 over 4 which gives us 0.625. And then just to double check that we have all of our math right, let's go ahead and just revisit this. So probability of market A plus the probability of market B plus the probability of market C is equal to 1. Well, we've said that the probability of market A is equal to 0.125. We said that the probability of market B was 1/4 or 0.25, and the probability of market C was 0.625, which is equal to 1. So therefore 1 is equal to 1. So we have all the correct probabilities aligned here. Okay, so we now have the probabilities of each of these markets occurring. So that's good. So this has been a bit of work to get to this point, but the good news is we're here. So let's look back at our table then. And what we can do then is we can just write in our probabilities here just to remind us. So this occurs with a probability of 0.125, 0.25, and 0.625. Okay. Now, what we need to remember is that we're calculating the expected opportunity loss. That's what the question is asking us, and it's telling us, an expected opportunity loss is simply the sum of all possible regrets of the alternatives, each weighed by the probability of that state of nature occurring, okay? So what we're going to say is our EOL, and now we're going to identify the best possible scenario in each of these market conditions to set our base of regret. So if we chose 14, we'd have 0 regrets. So 14 minus 9 is equal to 5, and 14 minus 11 is equal to 3. If we chose 10, we'd have 0 regrets. So 10 minus 7 is equal to 3. And same thing here. If we chose 12, we'd have 0 regrets. 12 minus 10 is equal to 2. And 12 minus 8 is equal to 4. Okay, now all we're going to do is we're going to multiply these regrets. So EOL DIY is simply equal to the regret times the probability that it occurs. So in this case, we have a regret of 5 times 0.125. We see plus 0 times 0.25 plus 0 times 0.625. So this is just equal to 5 times 0.125, which gives us 0.625. So 0.625. Our EOL for van life is going to be 0 times 0.125 plus 3 times 0.25 plus 2 times 0.625. So 3 times 0.25 plus 2 times 0.625 gives us an EOL of 2. And then finally for our cooking show, EOL cooking Well, this is 3 times 0.125 plus 0 times 0.25 plus 4 times 0.625, which gives us an EOL 3 times 0.125 plus 4 times 0.625. 3 times 0.125 plus 4 times 0.625 gives us 2.875. So following the expected opportunity loss, we're going to select the decision with the lowest expected opportunity loss. In this case, the lowest expected opportunity loss is our DIY home improvement. Okay, so the expected opportunity loss by selecting DIY home improvement is simply $0.625 million. Now, finally, we have to calculate our expected value of perfect information. So our EVPI. So if we had perfect information, what is the expected value of that? So let's just go ahead and paste our table in again, and again we'll just write in our probabilities. So this was 0.125, this was 0.25, this was 0.625. And all we're going to do is we're first going to find the expected value of each of the following scenarios. Okay, so our expected value of DIY is equal to 9 times 0.125 plus 10 times 0.25 plus 12 times 0.625, which gives us an expected value of 11.125. Then we're going to calculate the expected value of van life, which is 14 times 0.125 plus 7 times 0.25 plus 10 times 0.625. So 14 times 0.125 plus 7 times 0.25 plus 10 times 0.625 gives us an expected value of 9.75. And then we're going to calculate the expected value of cooking, which is just equals to 11 times 0.125 plus 10 times 0.25 plus 8 times 0.625. So 11 times 0.125 plus 10 times 0.25 plus 8 times 0.625 gives us equals 8.875. So we'll just write them up here just to keep it simple. So 11.125, 9.75, and 8.875. This is all in millions of dollars. Okay? Now, our EVPI is simply equal to our EVPI is equal to what we call the EPC, or the expected value of perfect control, minus our maximum expected payoff, our maximum EP. So we need to look at our table here, and we need to identify what our expected value of perfect control equals. So when we look at this, what we're looking for is the best case scenario across all market conditions. So in market condition A, the best case scenario is 14. In market condition B, the best case scenario is 10. And in market condition C, the best case scenario is 12. So what that then we do is, to calculate our EPC, we're simply going to do 14 times 0.125, that's the probability that that occurs, plus 10 times 0.25 plus 12 times 0.625 minus our max EP. Okay, so 14 times 0.125 gives us 1.75 plus 10 times 0.25, which is 2.5, plus 12 times 0.625 plus 7.5 minus max EP. So what then? 12 times 0.625. Sorry, this isn't, yeah, so that's 7.5. So 7.5 plus 2.5 plus 1.75 gives us 11.75 is our EPC. And then we're going to subtract our maximum expected payoff, and we calculated that right here. Our maximum expected payoff is 11.125. So minus 11.125, which gives us 0.625. Again, this is in millions of dollars. So what you might notice is you might say, hey, well, the EVPI, the expected value of perfect information, is also equal to the expected opportunity loss. And absolutely that is correct. So if you know the expected opportunity loss, you automatically know the EVPI and vice versa. Okay? So the expected value of perfect information is saying how much it would be worth to you as a decision maker to have perfect information. So in this video, we've gone through the EPC, the maximum EP, the EVPI, as well as the expected opportunity loss, as well as how to calculate different probabilities when given different information about market conditions. And that's it for this video. Thanks for watching. If this video helped make business analytics easy, consider giving the video a like. And if you need additional help with business analytics, please consider subscribing to the channel. I look forward to solving many more problems with you next time.